So today I will be discussing about a fifth experiment, that is about a flip-flop. Okay, how to design and how to implement the flip-flop. So how actually the circuit looks. We are discussing about a master-slave JK flip-flop. Okay, there are different types of flip-flops. That is SR flip-flop and JK flip-flop, D flip-flop, T flip-flop. See, all these types of flip-flops are also there in your syllabus. I will be covering in depth in the fourth module. Okay. So right now, in order to understand this particular experiment, only a brief introduction I will be giving about a flip-flop and a very brief introduction about the truth table. Okay, I will not go in depth. I will not explain about the timing diagram and all, because in the fourth module you will be understanding a step by step. So therefore I will not touch more concepts, because if I touch more concepts, then in order to understand this concept I have to explain that. In order to understand the second I have to explain that. So like that there is a chain. So therefore whatever it is required in order to understand this particular experiment, only that much I will explain it. Okay. In case if you are having the doubts like how you have got this circuit, how you have got this truth table, all those things you will understand, but little bit later whenever I am explaining the fourth module. Okay. So what is this fourth experiment? So realize a JK master slave flip-flop. Okay. So before going to this JK master slave, you should know what is meant by the flip-flop, right? Because that is a very new term that you are hearing in this particular subject. So realize a JK master slave flip-flop. Okay, flip-flop using only NAND gates. Okay, you have to use only NAND gates in order to realize this master slave JK flip-flop and verify its truth table and implement it. Okay, so this is the experiment. What is the experiment? You have to design one of the flip-flop that has to be designed by making use of only NAND gates. What type of a flip-flop? They are asking to design master slave JK flip-flop, and you have to verify it truth table. TT means truth table. Okay. So before going to the actual concept, okay, before going to the actual circuit, I have to explain some of the basic terms. Okay. The basic terms means what is flip-flop, what is the pin configuration for 3-input NAND gate, what is the pin configuration for 2-input NAND gate. All those things you have to understand well before going to the actual circuit. Okay. So what is meant by flip-flop? This definition is very important in almost all Viva or in the question paper. They will be asking this: what is flip-flop and what is latches? Okay. Let me not use a new terms to you in this particular session, because we are just understanding what is meant by flip-flop. Let me not explain about latches and all, because in the fourth module from the basics you will be understanding. See how nicely the syllabus has been framed is, in the first module you are understanding the Boolean algebra, what is meant by AND gate, NOT gate, and again you are understanding about some of the analog circuits, you are understanding the photodiodes, analog to digital converter, digital to analog converter, current to voltage, voltage to current. So some basic things you are understanding in the module number 1. Coming to module 2, so if you want to simplify one particular expression, what are all the different types of techniques are there? So the first technique is a Boolean algebra technique, by making use of some laws. Okay, by making use of some laws you are simplifying the expression. So this is a general thing that you have already learned in the previous semesters or in your lower classes. But in the second module what you have understood is about a Quinn-Mikkleski method, about EVM, that is a map entered variable method, and likewise you have under multiplex in the Hege implement module. So all such different problems and different concepts you have learned in the second module, and in the third module you are understanding the design part of combination circuit. Okay. So and again in the fourth module you will understanding some new terms like what is a flip-flop, what is latches, and how to implement this whole design in one of the software by making use of a language called VHDL. Okay. In the fourth module where they are introducing a new language called as a VHDL. Okay. So don't ever come to the conclusion why I have to learn this multiplexer, demultiplexers, encoders, decoders, being a computer science student or information science students. Don't come to that conclusion. See, you have the subjects like computer networks, and you have the subjects like network security. So these subjects only you will be understanding the transmitting and receiving protocols. Whenever you are using such terms, at that time you have to go through the concepts of encoders, decoders, multiplexer, demultiplexer, all those things that you have to that all those concepts will come into picture again. So whenever you are understanding these basic terms related to electronics, being an engineer, it is very easy. So to understand the next level subjects. Okay, fine. We'll come back to this. So what is a flip-flop? Flip-flop is a circuit, electronic circuit with a stable states. It is not unstable. Stable andre a firm state. Okay. A flip-flop is an electronic circuit with the two states. Okay, with the two stable states that can be used to store the binary data. Okay, so flip-flop can be used to store the binary data, and it is an electronic circuit with the two stable states. It will be providing the two stable states. All those states we will just listen. And you know what are those two stable states, right? In the binary form, it will be either 0 or it will be either 1, right? So a flip-flop is an electronic circuit with the two stable states that can be used to store the binary data. Stored data can be changed. Okay, whatever the data that you are storing in the flip-flop, that can be changed by varying the inputs. Okay, by varying the inputs, you can change the data that whatever you are storing it. They are used as a data storage elements. They means flip-flop. Okay, have you all understood the basic definition of a flip-flop? Flip-flop is nothing but an electronic circuit, okay, which will be providing the two stable states, and that will be used to store the binary data. That it can store either 1 or it can be stored either 0. You can change the stored data by giving a different inputs. Okay, whenever I am explaining the truth table, you will understand how to vary the inputs and how to change the stored variable. Okay, stored binary data. If based on changing the inputs, how your stored data will get changed. All those things you will understand whenever I am explaining the truth table. So right now you don't bother about the latches and all. So just understand flip-flop definition is this one. Next. So why I am explaining this pin configuration, because they are telling that you have to design this flip-flop, that is a JK master slave flip-flop, by making use of only NAND gates. Since they are asking you to implement by making use of only NAND gates, you should know the pin configuration of NAND gate, the 3-input NAND gate and the 2-input NAND gate, because in your circuit, okay, in this circuit, that is the JK master slave circuit, they are using a 3-input NAND gate and they are also using a 2-input NAND gate. Since they are using both of it, you have to know the pin configuration. Why you have to know the pin configuration? By knowing the pin configuration only, you can write the pin numbers in the circuit diagram. Okay. So have you all remembered how to write the pin numbers? In the half order, full order, we have already discussed, right? How to write the pin numbers and all. So if you know the pin configuration of both 3-input and 2-input, then only you can write the pin numbers for the given circuit. Okay. So how they have connected for the 3-input NAND gates? So if you just observe this pin configuration, so what is the IC number for 3-input NAND gate? It is 7410. Okay. No need to remember this pin configuration, because in the exam they will be providing the charts of 7410, 7400, all pin configuration charts ninge kodtare exam alli. But you have to remember this IC number. Okay. You have to remember an IC number, because you have to ask, I want the pin configuration chart of 7410, then only you will be able to give it. You cannot come and ask, give the 3-input pin chart, all those things. No. You have to remember the pin IC number for 3-input NAND gate and 2-input NAND gate. 3-input NAND gate pin number is 7410. 2-input NAND gate pin number IC number is 7400. Okay. So now how this pin configuration, or what is the internal structure of this IC is? So how many gates are there? How many gates are there? How many NAND gates are there? There are 3 NAND gates. Okay. So the 3 NAND gates are of 3 inputs, right? See here. So the first is input 1, yellow color, whatever I have written in yellow color, that is input 1. Okay. Input 1 and input 1. So pin number 1, 2 and 13 are the inputs for the first NAND gate, and 12 is the output of first NAND gate. Next, input 2. The 3, 4, 5 are acting as inputs for the second NAND gate, and 6 is acting as the pin number 6 is acting as the output of second NAND gate. Next, whatever I have written in a green color, that is 11, 10, 9 are the inputs of the third NAND gate, and 8 is the output of third NAND gate, and 7 is always connected to ground, and 14 is always connected to the power Next, coming to 7400, it is similar to that of AND gate, right? So 1, 2 will be acting as an input for the first NAND gate, and 3 is the output of first NAND gate. 4, 5 are inputs, 6 is the output. 8, sorry, 9, 10 are inputs, 8 is the output. 12, 13 are inputs, and 11 is the output. 7 is the ground, and 14 is connected to positive power supply. So this NAND gate is already we have, I think I have already explained this pin configuration. So this is a new IC that you are learning. So this is what the internal structure of the 3-input NAND gate. By understanding this particular pin configuration and the internal structure, we can write the pin numbers for the given circuit. And I will be writing the master slave JK flip-flop circuit. Only the circuit you have to implement it, and you have to check the output by verifying the truth table. That is your actual experiment. Okay. So I will just write down the circuit. Okay, there is nothing logic explained in this particular circuit. So this circuit ಹೇಗೆ connect ಆಗಿದೆ ಅನ್ನೋದನ್ನ 4th module ಅಲ್ಲಿ ಹೇಳ್ಕೊಡ್ತೀನಿ ನಾನು. But right now you just take down the circuit, that whatever I am going to write it here. Okay. After writing the circuit, we will write down the pin numbers by just looking into the pin configuration. Right? Okay, fine. Please take down the pin configuration as well as the definition of the flip-flop. Then we shall write down the circuit diagram for the